Hi everyone, welcome to Back Direction. We believe on reshaping the tradition of learning. Today, let us start with class 10, chapter number 9, Carbon and its compound, lecture number 2. Now, in the previous lecture, we did the introduction of this chapter. We discussed what is carbon, what is the atomic number, and how it is present in our nature. Now let us discuss more about carbon. Allotropes of carbon. Now there are two types of allotropes of carbon are available. The first form is crystalline form and the second one is amorphous form. Now crystalline means you can say that the example of crystalline form of carbon are diamond, coal, and there are other two. Now, and amorphous examples are nothing but chalk, lead, pencil lead, and sugar. And there are many more. Now, if you see the picture and if you see the difference between this crystalline and amorphous, then we can clearly see that crystalline form are nothing but very solidified and they are very hard in nature. And if you see the amorphous example, chalk, lead, and sugar, and they are, you can say that hazy in nature, they can be easily breakable, right? But if you take the example of diamond, then it is not easily breakable. If you take the example of coal also. So these are the two allotropes of carbon which are present in the nature. Now let us understand the crystalline form in detail. Why this form is very hard and very strong. So basically the crystalline form of carbon are available in the form of diamond, graphite, and Buckminster Fullerene. This three type of crystalline form is present. Now, if you see the diamond structure, so this is nothing but your diamond structure, and if you see that every circle is your carbon, and if you carefully notice this structure, every carbon are very compactly arranged, very compactly bond with the other carbon, and this bond is very strong, and this chain will continue further and further and further and so on. So if you see that every carbon are bond this much tightly, then and the structure is very huge, then you just see how strong this structure will be. So that's why diamond is very hard, because the bond between this carbon and carbon is very strong, and number of carbon are arranged in this manner. On the other hand, if you see the graphite is the amorphous form of carbon. Now, why it have amorphous property? Why it is hazy? Why it is not? It is also a compound of carbon. Then why it is not hard? So the nature of amorphous and the crystalline, it's depend on the how the carbon is arranged in the atom. So on the basis of that arrangement of carbon, the crystalline and amorphous form is defined. If you see that here, every hexagonal corner have carbon. Every hexagonal corner have carbon. Now, every hexagonal is attached with each other. And if you see that the arrangement of this hexagonal sheet is nothing but one is at the bottom, and on the upper one, the big, you can say that big portion of the hexagonal structure, and so on it will proceed. Now, if you compare this structure and the graphite structure, then okay, we can see that this carbon have strong bond. But if you see this two layer, this is my first layer, this is my second layer, and the layer will be continue. If you see that the difference between this two layer is very large, and if this much distance you have in between two carbon, then this bond is very weak, because this two carbon have huge and large distance, so that the bond is weak bond, and that's why graphite have amorphous quality, and that's why it is hazy, because the bond between two carbon is not that much strong as diamond have. So basically, the crystalline and amorphous nature of a carbon compound is based on the arrangement of carbon in that compound. Now, if you take the example of Buckminster Fullerene, then you can see that it is resemble a football structure. So here also every hexagonal have carbon, and the total carbon present in the Buckminster Fullerene is only 60. So just imagine, if there are only 60 carbon, then the fullerene have very small in the nature. So this is a carbon compound which is very small, it is present in very small quantity, very small, because it have only 60 carbon. So this is how the carbon have all are made up by carbon, but everyone have different qualities because of the arrangement of carbon in that structure. Now let us understand the versatile nature of the carbon. What other nature this carbon have? So basically, the carbon have catenation properties. So the catenation of carbon is divided into two parts. So the first part is nothing but it contain further two part. It is also divided into two parts. So the first one is saturated carbon group, and the second one is unsaturated carbon group. So the saturated basically have straight chain reaction, which means that every carbon is attached with each other in a straight chain, and you can see that every carbon have single bond. And there is one more group in the saturated carbon is branch group. Here also you can see every carbon is attached with the single bond, but it is branched, that's why one carbon is branched with the single bond only. And the third group is, you can call it as closed chain. Here if you see that all carbons are arranged in a cyclic form or in a closed chain form, and the example is fullerene also. And here also you can see that every carbon is attached with a single bond. So these are the group of saturated carbon which have single bond, which are arranged with the help of single bond, and they come in a group of alkane. This single bond group and the saturated carbon group is known as alkane. Now next you have unsaturated. Now unsaturated mean the carbon are not stable. Saturated mean the carbon are stable, and unsaturated mean the carbon are unstable. Now why it is unstable? Why we call it as unstable? Now if you see, the bond between these two carbon is double bond. So because of this double bond, this carbon is unsaturated carbon, and the group of this unsaturated carbon and the unstable carbon and the double bond carbon is known as alkene. So every double bond group of the carbon is come into the group of alkene. Now the next one, the next unsaturated carbon is triple bond carbon. Now, if you see that the two carbon have triple bond, Again, they are also unsaturated carbon. And this triple bond one come in the alkyne. So every triple bond carbon is come in the group of alkyne. If you notice that every group have only last three alphabet difference: ANE, ENE, and BNE. So please do remember this group name and saturated and unsaturated. The second catenation part is nothing but valence of 4. Now this is only possible with the oxygen, and that's why you have carbon dioxide in the atmosphere. Now what carbon do? Carbon have 4 valency. So here what they do, they share with two oxygen molecules. So they share the two electrons with the oxygen and the other two with the other oxygen. That's why you have CO2. So this is only possible with the oxygen. Now let us understand saturated carbon group in detail. Now as I said that saturated carbon have single bond. Now what does it mean? What do you mean by bond? Your very obvious question, what is bond? So bond means, carbon have 4 valency. It means that this is my carbon nucleus, this is the outermost shell, the atomic number is 6, and how the 6 electrons are arranged like in this manner. S shall have 2 electrons and P shall have 4 electrons. Now these 4 electrons are basically balanced electron. So if they are balanced, then they want to make a relation with some other element. So how they do, how they share the electron and how they make that relation. So basically what carbon do, carbon have 4 valency, so carbon want to fulfill this valency, but no one is agree to fulfill this valency. No one want to make a relation with this carbon. So basically what carbon do, carbon ask another carbon, and they want that, okay, we will make one bond. So like that they share one electron, like that. And if they want to make the bond, then they want to make one thing, because of that they can make that bond strong. So this line, you can see that this straight line is representing the bond. It means that they are showing the relation between two carbons. Okay. So whenever the two electrons are attached with each other, they are attached with the help of this single straight line, and this single straight line is called it as bond. Now your saturated carbon have single bond. It's mean that uh, how many carbons are there? They all are arranged in with the single bond like this. Okay, if you take number 5 carbon, 4 carbon, 6 carbon, so all are arranged in the with the help of single bond. It's mean that carbon have 4 valencies. Every 1 valencies are occupied with the help of other carbon. You can see that. Okay, so this all electrons are attached with each other with the help of bond. Now if you see that other 3 valencies are still remain, now who will going to fulfill this, who will going to help this carbon? So basically to make relation or to make a bond with this other 3 and the valence electron, hydrogen come into the picture, because hydrogen also have 1 electron. No one is agree to have bond with the hydrogen. That's why hydrogen come to make a bond with carbon. Because if you take the other metal, so for example, iron, for example, copper, so this all are basically a metal, and metal have dominating character. So if they attach with carbon, they dominate carbon, and carbon don't want to dominate their cells. That's why the carbon never ever make bond with this metals and the other element in the periodic table. That's why they choose hydrogen to make a bond, because hydrogen is also very poor. The hydrogen also have one electron, so he is also searching to make a bond. That's why they both tie up. They do understanding in between us, and then the hydrogen is tied with the carbon, and finally you can see that if there are three valencies, three electrons are left. These three electrons make bond with a hydrogen electron one by one. So it means that every three electrons of carbon, valence electrons of carbon, are going to attach with the hydrogen electron like this. So this is how carbon fulfill their valence electron with the help of hydrogen. And you can see that everyone have the single bond like this. Right? So now here, if you see that the hydrogen is attached and hydrogen is ready to make a bond, so that's why now you cannot say that carbon name is carbon. Now if it is making bond with hydrogen, then you can, the name will be also different now, because hydrogen is there in the family. So that's why the name of this compound is known as hydrocarbon. So wherever the hydrogen are attached, they all are known as hydrocarbon. Okay. Now the saturated groups are basically divided into three parts. Straight chain. Straight chain means the carbons are attached in the straight chain manner, like this, one by one. So this will be a straight chain and saturated carbon. Now the second one is your branched. So the branch chain is basically you have straight chain structure of carbon, and one extra carbon will come and it will branched with any of the carbon. So it means that the branching carbon is known, this structure of carbon is known as branching carbon. And the other one is your cyclic. Cyclic, it means that there will be a triangular shape. It means that every vertices have carbon. There will be a square shape. Every vertices have carbon. It means that you have close chain reaction. Or you can say that cyclic also. Hexagonal, pentagonal. So every vertices have carbon. Right? Now let us name all the saturated carbon. Suppose you have only one carbon. Now carbon have four valencies. So as I said, if they have only one carbon, then who will going to complete this valency? Then hydrogen will come into the picture. So what hydrogen do? Here every valence electron are going to combine with hydrogen like this. Now if there are four hydrogen, then we can write this name, we can write the compound name is CHR4, that's why CH4. Now if there are two carbon, if there are two carbon, so basically this two carbon will make one bond with each other. Now remaining three valencies are going to fulfilled by hydrogen, And this is how you can write the formula for this C2H6. The third, it's mean that you have three carbon. Now I'm only explaining straight chain reaction. Carbon are attached in the straight chain manner. Now if you will have three carbons, so the three carbons will make bond with themselves like this. Now the remaining valencies are fulfilled by hydrogen. If you see that the end of two carbon have three valencies, but the middle one have only two. Why two? Because the remaining two valencies of electron are occupied with this side carbon. That's why the middle one only have two hydrogen valency. So that's why the formula of this three carbon are C3H1234567. Similarly, if you have four carbon in a straight chain, now there are four carbon, then again the remaining valencies are fulfilled by hydrogen. So here also at the end you have three electrons valency, and in the middle carbon you have only two valence electrons. So that's why the number of carbon will be 4 and the hydrogen is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, if you have 5 carbon, then the 5 carbon are attached in a straight chain. Now again, the end carbon have 3 valencies and the middle one have 2 valencies. Here I have one more. Other valencies are basically fulfilled by hydrogen like this. So if you write the name of this compound, it will be C5H12. Similarly for 6 carbon, similarly for 7 carbon, similarly for 8 carbon, like that. So this is all about straight chain carbon group, and they all are saturated and they all are known as alkane group. Now let us write down every compound name. So the first, if there are the number of carbon 1, then the formula will be CH4 and it is known as methane. The second, it means the number of carbon is 2, it means that C2H6, then it is ethane, because they form alkane group. That's why at the end you have AN2. If you have 3 carbon C3H10, then it is known as propane. If there are 4 carbon C4H12, the name of this compound is known as butane. If you have 5 carbon C5H14 is known as pentane. 6 C6H16 is known as hexane. And 7 C7H18 is known as heptane. In your syllabus, you have only till 6, but want to remember the 10th one, but now the screen is not sufficient, so that's why just remember till 7. Now if you notice that the parent name is nothing but meth, it, prop, but, pen, hex, and hep, and it is forming alkane group. That's why you have the last 3 letter ANE. So this is all about saturated carbon group which have single bond. I hope you understood today's lecture, and this will be the total table. This will be the overall table of the carbons. Whatever I explained you, this all are written in this table. This is still hexane, but do remember the seventh one is heptane. So I hope you understood today's lecture. Thank you for watching my video.